Yoeven here from JigsawStack. My goal for today and the next few weeks is to record more videos like this one to talk about some of the APIs that we are building in JigsawStack. And one of the focus is to really go deep into some of the technologies and understand why some of the technologies we use today don't work out so well and how can we make them better using AI, of course. You can see on my screen that we have a Walmart receipt. We're going to be using OCR, combining OCR technology with Vision LLMs so that we can have better quality output from extracting OCR, extracting data from receipts, passport data, identification information, whatever it is, right? And how can we do that in an easy way? So let's get started. The easiest way to get started is go to JigsawStack, create a free account, and get your API key. You can just go over to the key tab, create a new API key, and basically you get a key. Then you can make requests to any of the APIs. All the APIs are in the documentation. Today we'll be specifically talking about this API called vOCR. So what we did is we took traditional OCR, which tries to use an algorithm or a model and understands the image and try to look for patterns, similar patterns to text, alphabets in different variants and different language. We took models like that and built and fine-tuned a Vision LLM that takes the input from the OCR model and tries to better improve the quality of the output by understanding the context of the image that you have passed in and not just looking for patterns within the image and alphabets and matching them. So you actually understand, okay, this is a passport. I'm actually looking for an identification number. Where would it be? How would it look like? And try to extract the relevant context. So I have a few demos set up. We're going to start by extracting data from a Walmart receipt. As you can see, it's a pretty bad receipt. It's angled. It's difficult to extract from a typical OCR. And now we're going to extract this with JigsawStack's vOCR. So here I've set up an example. We have pasted in the image. It's the same image on the left, right over here. And all we need to write is the prompts of the values that we want to extract. The brand, we want to get our Walmart or whatever receipt that we pass in. Subtotal. So as descriptive as we can be, I think for right now we just need to get a subtotal and the date purchased. Total items, so we're going to get a total number of items purchased. And then we can just pass this image in, right here is a URL, and send an API request. So we already passed in the API key in our authentication, we send an API request, cool, we got the structured data out. You got the brand, you got the subtotal, which seems to be accurate, yep, 68.06. We got the date purchased, where is the date purchased? Oh, nice. Okay, it's here. Even my eyes is slower than the OCR. And total items 13. Perfect. You should pass in the thing that you want and write the prompts that you need. What's interesting is that a lot of times using a lot of the VLLMs we have today, you get a lot of unstructured data. In this situation, you get structured data, but you also lose a lot of things that you typically would have in OCR, like bounding boxes, pixel data, where in this image is that piece of data. We took it one step further, and we still provide line-by-line structured OCR data. You can see a Walmart structured out, the pixel data, specifically where in the image it's that text extracted from it. Let's do another example, and now something a bit more difficult and a bit more privacy friendly, right? So we have identifications like that. So I have this identification, we have pasted in an image, I think so. Okay, let's start with California ID. So we have an image over here. As you can see, this is the information that we want to extract. We have written a prompt, first name, ID number, expiry, date of birth. It will try its best to go in and extract the information that we want. We send a request. It should go in and extract all the information we want. It understood what LN meant, it understood what FNN meant, because again, we're using an LLM under the hood, which has some level of context understanding. And this LLM has been fine-tuned specifically to take in OCR data like we have at the bottom, so it always has structure that we can output and you can actually use in your backends or in your product. The expiry date, that's the date of birth, yeah, correct. And the expiry date, perfect, cool. And you have some tags that tell you what this image is, and all the OCR data that you typically would get, all broken down by line and word and pixel data if you would need to. But typically, most people just want specific information from the image they pass in, and you have it over here. Let's try a Nigerian passport. Let's give that a shot. Let's paste the link in. Alright, let's double check is the image correct. Nice, works. First name, same set of prompts. Without changing the set of prompts, we can extract this information that we want from any type of image without having to readjusting or write code specifically for the image. Nigerian citizen, perfect, cool. I combine the middle name, considering that as the first name, last name, proud. The ID number seems to be correct. Expiry date, perfect. Right over here, and date of birth, yeah. That's basically the OCR. So this can be applied across a wide range of receipts, invoice, documents, and what's interesting is that each time you run the API, it spins up serverless sandbox with the model inside, so that none of these images are actually stored. So if you're trying to pass in a secured information or secured document that you need to extract information from, it's all done in a sandbox environment that instantly gets killed the moment you get a response, so that no information is stored permanently. And that's basically for every other API that we have in JigsawStack, so we can guarantee that consistency across all APIs. Yeah, so I hope that showcased the power of Vision OCR, and we're still making this better. Have a good day.